So while chemists were discovering that matter was discrete, that atoms existed, and that Dalton's laws were obeyed, physicists um, were discovering Newton's laws of physics and the forces that govern the universe. And eventually, these discoveries that the physicists made transformed our chemical understanding of atoms. And so we're going to go into that today. And we won't need all of the physics of Newton's laws. We'll just need the second law, Newton's second law. Which states that the sum of the forces is the mass times the acceleration. And you can see there are little arrows on top of the F and the A. That's because there's directions in all this. It's easiest with examples. Here's gravity. And here's a little ball. Here's the Earth. And the gravitational force, you know, the ball is downwards towards the Earth. And the arrow then means that the force has a direction. And the magnitude of the force is the mass times the gravitational constant, Earth's gravitational constant. And it obeys Newton's second law, force equals mass times acceleration. And as you know, the acceleration is downwards. The ball goes downwards, accelerates downwards, and that's because mass is positive. And when the mass is positive, the direction of the acceleration and the direction of the force is the same. So whenever the thing in between is positive, it's the same direction. Whenever it's negative, it's in opposite directions. The second force is electrostatic, electric force, between a positively charged magnetic plate and a negatively charged magnetic plate. And between those two plates, there's something called the electric field. And the electric field for uniform charge plates is uniform across the plates, and it points from the plus charges plate to the minus plate. And the law is force electrostatic is the charge times the electric field. So if we were to consider a negatively charged particle, negatively charged, there's a minus there, it would be then, that's a minus E and F, those directions are opposite, so the electric field is up, the electrostatic force is down. And then by Newton's second law, mass is always positive, acceleration and force are in the same direction, acceleration is also down. And so a negatively charged particle is attracted to the positive plate, opposite signed charges attract. And the third force is the most interesting in many ways, is the magnetic force. And it's between a north pole, let's make it a uniform north pole, and a uniform south pole. And between a uniform north pole and south pole, there's something that's called the magnetic field. And in this case, our magnetic field is pointing to the back, behind the paper. And now we can have a charged particle, make it a minus, and it's going to be moving with a velocity v. And the law is F magnetic is QV cross V. That X is a cross, and it means perpendicular. And it gives us a chance to do a little hand exercise. And the hand exercise is that you need to take your 3 fingers. And if we're doing a negatively charged particle, you'll use your left hand. And if it's a positively charged particle, you use your right hand. So here we have a negatively charged particle, use the left hand. And take your three fingers, and what you want to do is turn them so that they are all perpendicular to each other. Everyone do that, please. Turn your three fingers, they're all perpendicular. And the fun is not over. You got your three fingers all perpendicular, and you're going to practice in flip class. And your forefinger is the direction of the velocity. So turn it in the direction of the velocity. Okay. And your middle finger is in the direction of the magnetic field. It's moving backwards. And your thumb is the force. So there, the velocity is moving from left to right. The magnetic field is going backwards, and the force is downwards. This is hurting my hand. So I'm going to put my hand out, and I'm going to let you do this on your own right now while I just record what we discovered. The uh, oops, the magnetic force is downwards, and you see that the B, the V, and the magnetic force are perpendicular to each other, and we used our left hands. And the force is always in the same direction as acceleration because mass is positive, so the acceleration is downwards. And these are the three forces used carefully, which upended our understanding of the atom.